Today we are starting our chapter 9 focused on inequalities. Inequalities have a variety of answers, not just a single correct answer. So we're going to be working on the very basics today, and then as the chapter goes on, we're going to grow from that start of knowledge. So most of this should be review today, but it's always good to refresh your memory. So let's go ahead and start our notes. Let's get some light on here. Okay, so like I said, today we are working on inequality basics. And just kind of a little refresher here. So the very first part that we're going to look at is if we have an equation and we want to turn it into an inequality graph. And so our first example is going to be negative 3x plus 4 is greater than 13. Now, for the majority of the times we're solving, we simply solve the same way that we would for an equality. So we're going to solve for x. So we're going to start by doing the opposite of adding 4 to each side. And that gives us negative 3x is greater than 9. Now we are going to go ahead and divide both sides by negative 3. Now this is the one that people get confused quite a bit about. When you are dividing by a negative, you need to flip the inequality. So that becomes x is less than negative 3. X is less than negative 3. And the reason why this is the case is I'm sure everyone would agree that negative 2 is less than 5. If I multiply or divide, let's just say by a positive 2, then that would be negative 4 is less than 10. And that checks out. That is still a true statement. However, if I start with that same inequality, negative 2 is less than 5, and I multiply it not by 2 but by negative 2. So I multiply or divide by a negative number. Negative 2 times negative 2 is 4. 5 times 2 is negative 10. However, as you can tell, if I set my inequality, it is no longer less than. 4 is actually greater than 10. So notice that didn't happen when we multiplied by a positive number, but when we multiplied by a negative, in order to keep the statement true, I needed to flip that sign. So we need to flip your inequality when multiplying or dividing by a negative number. Okay, now this is only the very last step when we're multiplying or dividing. It doesn't matter what we here add or subtract. It doesn't matter if this one's a negative over here. It's always the coefficient of your x that you're solving for. So once again, we're going to graph this. So let's go ahead and do a number line, which is what we're going to do whenever we have one of these that is just one variable. When we have x's and y's, we won't be graphing it on a number line. We'll be graphing it on a coordinate grid. So 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. Okay, so step number 1 is to plot your point. And as we plot our point, you're going to plot your less than or your greater than, and that's going to be plotted as an open circle. However, if you have a less than equal to or a greater than equal to, that is going to be plotted as a closed circle. So as you can tell from ours here, we have a less than. So we look at our key, less than tells us to make an open circle at negative 3. Okay, that's step 1. Step number 2 is to shade. So this is less than. We know less than is to the left. And it kind of looks like an L there. And then greater than is to the right. Another little trick that I've heard is if the X comes first, you're going to shade the side that looks like that arrow. So as you can see, that less than looks like this over here. So I would shade that in. And then finally, step number 3 is connect. Okay, so we're going to go ahead and connect your point to your inequality. And what this means is that all of your answers, not including -3, but to the left of -3, are going to make this equation true. So if I plug in a -5, it's going to make this inequality true. If I might plug in a -22 for x, it's going to make this inequality true. But if I plug in a -2, it'll be false. So all of my answers are less than -3. Okay, so now we're going to go ahead and go the other way, where we start with our graph, and we're going to change that into an equation. So we're going to be working backwards this time. Try and keep my paper straight there for you guys. So we're going to go ahead and take a look at, once again, a number line graph. And we're going to go ahead and make a closed circle at 4. And we're going to go ahead and have that go to the left. Okay. So step number 1 to make this happen is to simply write down an x. Easy enough. So we're going to go ahead and write x. Step number 2 is write down your shaded arrow. And this, of course, you see your shaded arrow is this direction, and that looked like this inequality, like that. Step number 3, and this is a sometimes step, add your equal to underneath if it's a closed circle or a closed point. And as you can see, it is, so we're going to make that an equal to. And finally, step number 4 is write down the boundary point. And what I mean by boundary point is where your dot is. So as you can tell here, my dot is at 4. And that's all there is to it. That's how we change a graph to an equation. However, our next level of difficulty that we worked on these is you're going to have ones that are a single dot and a single arrow. So for example, let's say that I have a graph with a closed circle at -1 and an open circle at 5, and those dots are connected. Okay, so step number 1 for this process is write your x down once again. It's going to go all the way there. Okay. Step number 2 is write less than and less than on both sides of x. So we're going to put a less than on that side and a less than on this side. Step number 3, add your equal to for closed circles. And as you can tell, I have a closed circle on the left, so I'm going to make a closed circle on my left. I don't have a closed circle on the right, so I'm going to leave that as is. Step number 4, write down your left number on the left and your right number on the right. Okay, so as you can see, my left number is at -1 and my right number is at 5. And that is turning that graph into an equation. And basically what this says is x is between the numbers of -1 and 5, including -1, but not including 5. So that means I could plug in 4.9999 as my answer, but I couldn't plug in 5. 5 would make that an incorrect answer. So this, ladies and gentlemen, is our inequality basics, and we're going to go ahead and get some practice.